Yeah.
Got 7 days. A week.
Oh, God knows what class will end, what the exam is for me.
Y'all got like a whole month.
I'm not even playing like that.
I know, right? 21 days.
We
20
have
days.
15 days.
All right, chi-square.
What?
We have 15 days left.
They have 20
like
days until their exam.
Yeah.
It's the 21st.
Oh, I'm not counting. I was counting exams. I was counting at the last day.
No, they're taking the
No, like
AP
our
exam on the
AP.
21st.
And our AP exam's next Thursday.
Their makeup day is the 21st.
Yeah, I know.
Yeah.
No.
That's why Brady's going and doing it on the 8th. All right,
That's horrible.
I want to see
Chi-square.
it at the graduation.
chi-square distributions for homogeneity wrap-up, test for independence, and we're going to do the M&M lab, and we'll get to review today. So I'm going to actually pass out the mock exam multiple choice. We'll start looking at that. We'll look at free response soon.
Can we
So-
go over that stupid bag problem on the prior check for Mr. Guys?
Yes, you're talking.
That was really.
No, it was
Hey,
not. I literally
hey,
crashed
Jesus,
out.
it's cold in here. Thank you, it's cold.
All right. So I just want to, hey, real quick, I want to recap on a couple of details. When we are doing a chi-square test for goodness of fit, remember we don't have a statistic or a parameter to define, but if the data is statistically significant, then what do we need to do? We need to, well, obviously reject the null, but then afterwards, what do we got to do?
The follow-up.
The follow-up analysis, what contributed the most? I actually looked at the, obviously, it makes a lot of sense. One of those missed questions on the mock exam was about those expected values or what was the component or something like that.
Why?
I know, it's like we hadn't gotten there yet. I'm just, you know. One other thing I want to say, because I was reading back through the textbook, just to really firm up a couple of things from my knowledge. I do want to point out, when it comes to your hypotheses, okay, one, make sure you do not reference, any guesses?
Huh?
When you are doing hypotheses, correct, do not reference the sample. All inference procedures are about a what?
Population.
Population. So don't mention the sample in your hypotheses here, okay? And in the textbook, they did say at least 2 of the proportions are different. I still think you can stick with at least 1, but yeah, if at least 1 is different, then at least 2 have to be different. And so the textbook did word it as at least 2 are different, okay? So, there you go. Make sure you do not reference the sample, and then 2, the alternative is at least 2 are different. All right. Then we got here, now I left this slide in, and I just want to point this out because I was a goof. I did make a mistake here. So, how many samples were selected? 2. How many populations were there? 2. How many variables are we measuring?
3.
It is 1 variable, that's my fault.
Yeah, I was right.
Yeah.
Oh,
It is 3 categories.
It's kind of, is this just kind of like the level?
Right. So, it's only 1 variable. It is the admission decision. So I'm glad I did some more research and refreshed my understanding on that. It's 1 variable, 3 categories here. And so, it'll matter a little bit later. Okay, so we got to this point yesterday. Did we actually run the hypothesis test?
I don't know.
Yeah.
I think we did. Oh yeah, because I showed you all how to create the
Oh,
matrix, right? And so it was nice. Now remember, where should you run your actual test? And what kind of page on the calculator?
Calculator page. Stat and list page.
Is it a calculator page or the list and
The
spreadsheet
list and
page?
spreadsheet.
What was the benefit of doing the list and
You
spreadsheet?
You can see the,
The,
The expected matrix and the component matrix, you can actually see those values, okay?
Okay, here we go.
All right. I can't remember if we finished this. Oh, I did do the real reason. So Peter, you were asking how do we know the shape of the chi-square distribution and where to mark it? See, I knew Nate wasn't going to let me down. Hey, sir, thank you.
Oh, that's it.
Wherever makes your heart happy.
Wait, when, are you graduating?
Yep.
Wait, why'd you have to check in? I don't know, I just do it to be safe.
Yeah, you really don't have to check in.
I was about to say.
They don't count attendance, I just walk
Yeah.
in.
Alright,
Cool.
yeah. Okay, so real quick note about a chi-square distribution. I knew it was something like this and I could not remember. So, two things. One, the mean of a chi-square distribution is the degrees of freedom. Okay?
Jake.
So the mean of a chi-square distribution is the degrees of freedom. So you can do a sketch based on what your degrees of freedom is for what the mean is. Then the mode is the degrees of freedom minus 2. Okay? So let's say so what was my degrees of freedom in this case?
One.
Wait, like, 2.
It was 2. Okay? So the mean would be, which I actually need to draw a new chi-square. The mean would be 2. Okay? What would the mode be?
0.
0. And so this is a really weird chi-square where it looks like this. Okay? I will point out, so like this is the degrees of freedom for 2 for a chi-square. This it may be degrees of freedom of 5. And this might be a degrees of freedom like 18. What do you notice about the degrees of, or the chi-square as the degrees of freedom increases?
It becomes
More
more
variable.
normal.
It becomes more normal, 100%. So when the degrees of freedom of a chi-square distribution increases, it does become more normal, because in the grand scheme of things, my mode and my mean wouldn't be that far off. And if the mode and the mean are the same, essentially, it'll basically be normal. It won't ever quite get there, but it'll get close. All right. I know. So we did a test for homogeneity. The only thing I want to recap yesterday for the test for homogeneity is this. What are the hypotheses for homogeneity? Like when we are looking for a test for homogeneity, we are asking what question?
Like if the distributions are different.
Distributions are the same.
We're asking, ooh, that's actually a good point. We assume they are the same, and we're asking, are they different? So for a test for homogeneity, there is no difference in the distribution for our two populations, right? And notice we have to be clear about the population. We can't say there is no difference in the distribution of admission decisions for the sample. We have to say it's for the University of Michigan and Ohio State University, versus there is a difference in the distribution of admission decisions. So is there a difference or not in respect to our variable for those two populations? Okay, that's homogeneity. Today, so expected counts. Yep, totally mixed with that.
Gross lots.
I forgot I had this slide in here. The main thing here, expected counts. How do we calculate our expected counts?
It's the row total by the column total. Row total times column total divided by total total.
Okay. And how do we determine our degrees of freedom?
Category minus
Oh, it's
1.
like a
K
K
minus one.
minus 1 times.
So, yeah, what we'll do to make it easier is we'll do
Categories of
row minus 1 times columns minus 1. So remember when we talked about categories, we did K, right? So that's why we did K with categories, because we typically use C for columns with a two-way table. Okay, so that's my degrees of freedom. However many rows there are, minus 1, and then however many columns there are, minus 1. Michael, I will point out these are things that you may seriously want. since
Sorry, I
you're
got
not
an
here
email.
today.
I got an email. I didn't read it.
Look, he saw
It's
my
from UA, I had to-
just like putting it in.
Okay, just trying to help you out here.
Yes,
Okay.
sir.
4C method.
KKK?
What?
Oh my gosh, let's
What? Where do you see?
Serena's
Oh my
in-
God.
This is Serena.
I know, right? So the 4C method of inference for the chi-squared test for homogeneity
Is the same.
is the same. What's the 4C method for inference?
Choose conditions calculate.
Choose, check your conditions, calculate, and conclude. These have not changed, they will not change. Hopefully we're really comfortable we reject if our p-value is low, we fail to reject if that p-value is high because we understand what those things mean. Don't forget, when we're talking about a chi-squared goodness of fit, not goodness of fit, test for homogeneity, we are asking, are these what?
Are these
Or are
distributions
the-
the same?
Yeah, are the distributions for blank populations? And really what we're asking is, are we asking if they're the same or are we asking if they're different? If they're different, right? What do we assume? We assume they are the same. So are those distributions for blank populations
I am talking about
different?
right now. Stats.
Okay? So are they the same or are they different? Make sure it's all about the populations. The check, this is the only thing I really want to hit on. You could check everything. Yes, ma'am.
Does this show up a lot on the exam?
1 to 2 multiple choice questions. Well, I would say this. 1 to 3 multiple choice questions. If it's only like one question on multiple choice, it may also be a free response question. But if it's like 2 or 3 multiple choice, then it's probably not a free response question.
Please.
Now, I will say this. We're about to do one more. Actually, we're going to do 2 more with this to make it make more sense. But the ideas are almost the same as goodness of fit. It's just we're looking at these 2 different populations and checking those categories. All right. Check, calculate, conclude. All right, but let's do this one. So our taco tongue and evil eyebrow
No, I'm
independent.
We're tired of that. Oh my
We're
god.
bringing it back, baby.
No, bro.
Okay.
Leave it in the ground, bro.
It's not. All right. So I just need y'all to answer questions 1 and 2 to start. Okay. So I just need you to answer questions 1 and 2 to start. Work with in your small group. 1 and 2.
What?
I require your assistance.
Square formula, then how are these different?
Okay. So Serena is asking the right question. I need y'all to look up here, and I need to talk about this. So first off, the process for finding our expected counts was exactly the same, wasn't it? What I showed Michael and Lana that I want you to think about is if these events are independent, which is what we assume, right? What is the probability that someone has evil eyes or can do evil eyebrows and taco tongue? What is the probability that someone can do evil eyebrows and can do taco tongue?
So is it what you just showed us? The 200 plus how many times? Was it 480? That part?
You're missing something. Okay,
Divided by-
remember, if these are independent events,
Oh, then it should be the same probability of.
No, it's not given.
well, if they're independent events, the probability of evil eyebrows given taco tongue is equal to the probability of evil eyebrows. But that means their intersection is just what?
Evil eyebrow.
Oh,
Evil eyebrows.
Yeah. Times
Times
PT.
probability of taco tongue. Okay? So what was the probability of evil eyebrows? 200 out of 600. What's the probability of taco tongue?
480.
480 out of 600. And so that is the probability that someone can do taco tongue and evil eyebrows. That's just the probability. So how many would we expect to do evil eyebrows and taco tongue?
160 out of 600.
But how did you get there? Like, how could I use this to get the expected number?
1/3 times 4/5 times 600.
Okay, I'm just going to take this
Bro.
and multiply it by
600.
600, right? This is my probability times n. I will point this out. We can think of this and we should recognize this almost like a binomial distribution. Either they can do evil eyebrows and taco tongue or they can not. So our expected amount is just n times p, okay? With that in mind, what's 600 divided by 600? 1. And so I'm left with my column total times my row total divided by my total total. That's why this works here. Do I need to collect the
I think you do.
Yeah, I think so too.
Mine's just cigarette.
I think there was a reason why you had to separate them.
I know.
It was just a big deal.
All right.
We're not causing distraction.
You're causing me a distraction. All right, so what was it, 160?
Yeah.
And so this had to be
It was
40.
40.
I don't know.
This had to be
320.
one,
What are you doing?
It's 3, I got 3.
320,
Yeah.
Yeah.
and then this had to be
80.
I will point out, once you find one of these, or a couple of whatever, then you can fill out the rest. But row total times column total divided by total is our expected counts. Okay, so in this case, how many samples were there? One. And how many variables were there? Two. And so Serena is asking the question, well, how's this one different from homogeneity? The process for actually doing the procedure is not different at all. The difference is what we are checking. So also the conclusion, so the hypotheses and the conclusion. Because here's the thing, last time we were asking, are these two different populations? So we had one sample and we had a second sample. Are these two populations the same? Are they homogeneous? Here, how many samples do I have? I have one sample and I'm looking at two different variables for that one sample and asking, are these variables independent of each other? So it's the question that we're asking is the only difference. The way we run the test is the same. The way that we can conclude for the most part is the same. The difference is the hypotheses. That's it. So we do have to be careful and clear on that. All right, so let's go quickly through this because I want to get to some M&Ms. I'm just telling you. All right, I know. No, I don't think you understand. Like plain M&Ms are fine. Peanut M&Ms.
I have to agree.
Caramel M&Ms are the
Lay's,
best, bro.
Reese's are
See,
better.
peanut butter M&Ms are even better.
Reese's
than-
are
No,
better.
peanut butter M&Ms are
You're right.
good.
Reese's are awesome. However, Reese's
Reese's are the
Pieces
best.
are trash.
No, they are
Reese's in
not.
general
I'm
are
willing to.
trash.
No, they're
You
not.
take that
Both of
back.
y'all. Both of y'all remember that.
All
famous
right, right here. So choose the procedure. So we are testing for what?
Okay.
Hey guys, we are testing for association. So this is a chi-square test
For association.
for association.
Oh.
Bro.
You're doing it independent.
Okay. You can also call it a test for
It's okay, my Gloria's
independence.
king.
Okay, I thought it was a reason for nothing.
So you can say either a test for association or a test for independence, okay? Significance level, alpha equals
0.5.
0.05. Hypotheses, what are we always going to assume that there
No association.
there is no association or that they are independent? So the variables,
Taco time.
taco time, and write them all the way out, don't abbreviate like this, and evil eyebrows are independent, not associated.
Bro.
In the population. Notice how many populations am I referring to?
Do we have to say in the population?
Huh?
Do we have to say in the population?
I would actually include what the population is, so the senior students, right?
Okay.
So include that context. The alternative is what?
There is an association between the variables taco tongue and evil eyebrow and the population of senior students.
Are dependent
Three.
or associated. I should say not independent, which is dependent, but this is just more traditional. You just have to do independent, not independent, or not associated, associated. So, random,
Sample.
it was a random sample, we have that up here. Tell you what, if 600 seniors, it really is less than 10% for the entire school, that would be bonkers.
It doesn't say of the school though, so it's just
Oh.
senior students.
Okay, so
It could be like one of those Texas schools.
Bro.
6,000 seniors?
Yeah. Dude, have you seen
6,000? Like
I think,
six?
yeah, Loki Allen.
like Allen, bro? No,
Imagine being valedictorian of that class.
dude, they only have
No, you'd have to be a goat for that.
They have
like-
multiple
they have
valedictorians.
Oh, do they?
They have like
they got a
10,000
bunch of them.
students.
Like
Okay,
That's
15.
not freshmen.
What about large counts?
The 40, like the small
40 is the larger than.
So,
At least 6 freshmen.
smallest expected counts, or count, equals 40, which is greater than 5. Okay? Specific formula, so again, I would actually write this formula out. It's on your formula sheet. Chi-squared equals the sum of observed minus expected squared divided by expected. And I would
Are you looking at my
substitute a few of those values in. So what is that, 180? Minus was 160 expected?
Yeah.
Divided by 160 plus 300.
No, it was like 320.
Dude,
Dog, that says 300
are you
right
stupid
there.
or no?
Oh,
Be nice.
I see this every day, like.
I know, it's been too much.
That was funny.
Plus, can I say, I'm
I'm
funny.
gonna dot
Well,
that
That's
now, I'm
really
too lazy.
Sorry about
Let's not get too cocky.
that.
That's
It's
fair.
fair. By hand.
It's okay, my glorious king.
Serena.
No, I'm still on that green card though. That was. I haven't forgotten about that.
No, it's
Neither is Peter.
it's
Yeah.
It's AAPI done.
Okay, so there's my chi-squared, alright? Am I actually gonna do all that work and add it up and et cetera?
Heck no.
Yeah, use a calc.
Hard pass. Okay, so paper calculator. I'm gonna work back here to help them learn how to do this, but I need y'all to individually do this. Okay, so here's.
So scratch pad.
Move this real quick.
Get off that scratch pad, Serena.
I'm getting off scratch pad, dang.
Okay, actually.
I'll have scratch pad.
So when you go here and you go to that code, right?
Oh my
Not
god.
that one.
Matrix.
6 statistics,
Wow.
7 statistics.
Two by two.
Notice we have a two-way table now.
Oh.
Gosh, you
Jane, can you stop breathing in my face? It stinks.
Oh.
Yeah, but
I'm
if you
so
go
good,
to
like
the
the
two-way
really
test,
Wait,
notice what does it ask
Is
for?
our matrix the observed or the expected?
Expected.
I don't
Look,
know. It's not.
wait,
Look, if you go to the to this, what does it say?
Wait.
Observed?
It says observed. Okay, so,
Oh,
see how it says observed matrix? So what do we need? We need a matrix. Okay, so we didn't get a chance to do it in Algebra 2, but the calculator thankfully can do it all for us. Okay, so all you have to do with button, let's just do cool prep, menu,
I guess.
7, where it says matrix and vector.
No, maybe.
And then we're going to create a matrix. And then number 1 matrix. And it's 2 rows and 2 columns, right? Okay. So I'm just gonna, what I would do is if you hit tab, it lets you get to the next piece easily. Okay?
It's
So we literally
Alright,
just
so we just put our observed counts in there. So what was it, 160?
so I would.
Now I hit tab, 300 I think was next.
Peter, that's what my tested work.
I thought it
was.
was-
Is it chi-square
I had
test?
0.333
Sorry,
repeating
I
on
messed that first one up.
and then take that as
So
observed.
remember how it said observed matrix?
And just, do I put expected
20
on?
Observed.
and 100. Now, I need you to watch this. So you have 180. So here's what you have to do. Remember how we're gonna
How
have
does
to
it know what
enter
the
that
expected
matrix? So I've got to name this matrix. Okay? Right here above VAR, standing for variable, it's STO for sure.
Oh, wait, no, I think it's wrong.
VAR for
You said
variable,
doing
and
it
this is
right.
so control.
Wait,
Stored.
wait, no.
And I'm
could-
gonna call
Well, you-
this.
you
See
really-
the expected matrix is right here.
You know, I'm no,
Top
I just
right.
realized you could get the expected by just doing the totals and then like manually calculating it that way.
You can.
Or
But I try to make
I
it
just
somewhat
asked you, I
consecutive.
asked you.
Alright.
Observed, you said yes, and now you said you're saying.
And then
I don't think there is a-
No, it is observed.
Now
It
it's
just
stored.
shows you the expected
So if I
after you
hit
plug in the
VAR,
observed.
So 7.
Okay,
no.
so-
Like it gives it
Because
to
what
you.
Peter,
Okay.
expected.
You do, okay, your matrix is gonna be of the.
It's
Look, look at my
Okay.
chi-square.
You can, so don't do this.
Bruh.
You can go in here.
Oh no, how'd you get 0 and 1?
Yeah.
Two way.
Did you
Here.
base it?
Bruh.
Why is it called E?
Why'd you put E?
Notice
Dude,
it
that's-
gives us
that's
our
your
chi-squared,
expected. You
like
gotta
that's
put in
the
your
sum of all
observed.
those values that we just
The
wrote.
chi-square is-
Here's my
Bro, you're
value.
expected.
Oh.
The chi-square is 0 because you put in the expected,
I
and you put out the expected, bro.
Bro,
So the p-value of that happening
is
is.
I'm gonna actually do a
Yeah,
little
basically,
All-
because you can derive the expected
Menu.
from the observed.
statistics.
And then you want to save
stat
time,
test,
because they're lazy.
and I'm gonna do it 2 ways.
That sounds
here.
so
Wait, hold on, hold on, hold on.
confused.
Now, when I do it
Oh my
here,
God.
same exact
No.
chi-square, p
What are you
value,
trying to
degrees
do?
of freedom. But you see how I can actually see what the expected matrix is. And then we have 160, 320 on the top
Yeah.
row, 40 and 80 in the bottom row. and then those numbers up
Are
there
you
that I
trying to
just
hate me?
wrote out, the 180
Oh,
minus
okay.
160 squared divided
Stop,
by
sit down.
160, those
Okay,
are called
okay,
my
I'm
components. Here's my component matrix, 2.5, 1.25, 10.
Oh, my word.
So like if you were to actually do that
okay, I
work,
didn't-
you
Wait,
can
wait,
put
wait.
I even looked at
if you actually do that work, that's that component matrix, okay?
Oh,
All right. Yeah,
Oh, you're talking about the class?
yeah, I'm gonna talk about it.
Alright.
Do you have a question?
Oh, yeah, I was gonna ask you that. What is text?
Wow.
The guy split it.
Oh,
Okay, so, notice we did all this work, I'm gonna put it up here in a second. Now, remember, so this is, dude,
Dude.
stop.
You cannot.
I will say this, the chi-square distribution does not work very well when your degrees of freedom is only 1. And so remember, we said our degrees of freedom earlier is the rows minus 1 times the columns minus 1, and so how many rows were there? 2, minus 1 is?
1 times 1.
1 times, thank you, 1 times 1. So when the degrees of freedom is 1, the chi-squared graph actually looks like this.
I drew it.
oh, it's like an exponential decay.
It's almost like an exponential decay, right?
Nerd, bro.
And so it's very weird. Don't stress graphing it really for this one. You could do a picture. But what's our test statistic? What's chi-squared equal to?
18.75.
18.75. And I think if you look at that, if you look at the calculator, thank you. The degrees of freedom literally says what? 1, just like we got here. And so what's my p-value? What is the probability that chi-squared is greater than or equal to?
0.00015.
0, 0, 0.
There's a lot of zeros, I don't think.
Bro, that's not approximately 0. There's only 4 zeros in there.
Oh, is it only 4?
Yeah, it's 0.000015.
Close enough. All right.
That is not.
So, there's our p-value. Now, from that point, we should recognize, do we have statistically significant evidence?
Yeah.
Yeah, that there
Yeah.
is in this situation.
So, what would we conclude? We would,
Yeah, not gonna do that.
What? Reject
I will say, yeah, and I will say this, there's debate on what to start with. This is how I personally always start my conclusions. There's 4 elements you have to hit. Does anyone remember what 4 elements you have to hit?
Conclude
Yeah.
You gotta, well, you gotta
Oh, wait.
No.
address the null, so you have to make a conclusion about the null.
P-value.
You have to compare the p-value to
Significant.
the significance level to alpha,
Alternative.
conclusion about the alternative, and
Context.
context. Those are the 4 pieces of conclude every single time. They are checking for those 4 pieces every single time, okay? Interpreting the p-value is good, that's more for the multiple choice. And you will notice probably that they didn't even have that on the 2019 test that y'all took because that was the released international edition. They haven't released a new test since COVID when they did the course and exam description.
I wouldn't.
I wish they would, huh?
I wouldn't know.
Because he didn't do it.
Oh, yeah. I mean, you did the 2018 one, but you may want to do
Yeah.
the 2019 one soon because we were going to start looking at it. Okay, but personally, I just start with this.
Before we start.
I would reject the null hypothesis. Okay? I'm not even going to go into context yet. I'm going to go into context when I get to the alternative. So why am I rejecting the null hypothesis?
We do that. Alpha.
So since the p-value equal to 0.0000015 is less than the alpha of 0.05, explicitly compare them. So since that is true, there's what? Convincing evidence. I could not hear what you're saying.
Oh.
Statistically significant or convincing evidence. So statistically significant evidence of what?
Between being able to talk with tongue and Google eyebrow.
There's an association.
Okay, so I was like, I would go back to using that
Oh.
language about association or independence, that there is an association between being able to do evil eyebrow, and taco tongue. The other way I could say that is the events of being able to do evil eyebrow and taco tongue are not independent, right? So they are associated, or they are they're not independent. Now I will point this out. At this point, we said there's statistically significant evidence, right?
Yeah. Follow up.
So we got to do some follow-up analysis. Which part of this contributed the most to the chi-square test?
I don't know.
Well, go look at it.
Well,
Which
the
might-
hold
This
on.
doesn't really tell me anything.
Yeah, the calculator did tell me. Oh,
Probably
wait.
the bottom right. Probably better now.
Wait, how do you read this comp list?
Hold on, I'm
It's row, row column.
Dude, you just said some gibbery. Good.
It's row, column.
Oh, so what is the, yeah,
So what were the values? 180,
Oh, it's bottom
300, 220?
2100.
Was it 20 here?
Yeah,
And-
100.
Oh, bottom right.
100.
Okay.
Look.
So variable. No, I got
it's sort of by rows, so it's row one.
I don't like listening to you.
Yeah, funny.
Why are you looking like that?
Jane, I hear you, but she's just trying to push on you at this point. She's like, I'm not listening to anything.
These
you
are the
said.
columns and the rows, right?
Whatever you
Okay.
say.
So here we
Row
go.
one, row two, row two, column one. Row two, column one.
All right. So we have
You're
our.
gonna need this in the feature bubble.
He's about to explain it. That's why I wasn't listening to you.
Okay. So
What is wrong with
you
you?
can see it right here, or you can see it here. But Jaden is also actually right. Notice that's our expected matrix for row 1, isn't it?
Yeah.
Isn't that row 2? So when I go down to my component matrix, what is this? Row 1 and row 2. So what contributed the most?
The bottom line.
Row
The
two,
bottom
column one.
left. So row 2, column 1, right? So it goes rows. So row 1 is here. So row 1, column 1, row 1, column 2. Row 2, column 1 contributed the most. And that should make sense when we look at our data. I just want y'all to see. Yeah.
Half of what it should
So remember, I think was the difference between all of these and here 20?
be.
Yeah.
If you look at the observed versus the expected, the difference between all of these and each of these was 20, right?
Oh, 'cause it's
But how big is 20 in comparison to 180?
Pretty small.
like 9 times smaller.
It's not that big of a difference, is it? How big is 20 in respect to 300?
A lot. I don't know.
Smaller.
I'm just saying.
I just want you to think about the ratio of 20 to 300. How
I'm just
much is
saying
20?
something.
I know, but how much is 20 to 300?
300.
50.
Cray cray.
Okay, can we just agree that it's not that big of a difference?
Cray cray.
What?
Yeah.
20
Uh-huh.
in the span of 300, that's not that big, is it? Like,
Where's it?
20 is pretty small compared to
I
300.
guess
This
you
is
need more
about
context.
subject. This is subjective.
I was
No.
saying, you need more.
20 to 100 is like.
Like, do you mean?
Guys, when I, first off, we're talking about this context right here, right? And 300 is the biggest number up here. So when I compare 20 to 300,
It's an opinion.
Between the teacher.
Oh, well, I know what you're trying to get at
In
now.
my
I get it.
opinion, I feel
I
like
get it,
it's
I
not
get it,
true,
I
but
get
okay.
for the sake
I
of
have it
class,
now.
He's
On
trying to
20.
crash out.
We get it. We get it. Oh my
Not
god.
everybody
The way
does.
you worded it was confusing.
it's an opinion. I never said, look,
It's
you're
not.
you're entitled to your opinion.
You gotta
No,
Crash
that's
out.
like, I need you to hear this. 20 in comparison to 300,
Like circus.
20 is not that big in comparison to 300 when we have 20 to 180.
That's even smaller at 180. I'm confused. You're an idiot.
No, that's a higher, 20 is a higher proportion of 180 than 20 is of
Oh,
300.
that no, yes. I thought you were saying it a different way.
Yeah, I thought you were.
I thought you were saying
Higher
20 to
surface
30 is
volume
not
ratio
that
or
far.
lower surface volume duration.
But when we compare 20 to 80, 20 is a much bigger
I
proportion
thought
of
you were
80.
saying 20 is close to 30.
And what was 300?
Yeah, I thought you were saying 20 is close to 300. That's
No.
why, that's why I didn't agree with you.
I was confused.
But
See, we
what section contributed the most to the chi-square test statistic?
20, 40 to
The-
Something.
The 20,
40.
is that 40 there?
Well, the expected is 40.
Oh.
Whatever it is. Okay, regardless, that is close. So it created the largest chi-squared.
So how do we add that
statistic.
into our conclusion?
Well, so all we would need to say is the largest
Largest contributing.
component or contributing factor, contribution to the chi-squared is the
No taco tongue, yes.
event, no taco tongue, and yes, evil eyebrow.
That makes sense, because not very many people could do that in our class.
Right. I was like, there was not many people who could do the evil eyebrow and not do the taco tongue. That's actually true based on the data we literally collected. Okay,
Why are you laughing?
because he's Jake.
Are you high?
Yes.
Why'd you answer?
You like for
Okay, put your tongue back in your
Yeah,
mouth.
that's how I feel.
That's why I smell like that? I'm just playing. Because that was me. Okay.
Okay.
It's all Serena's fault. She got me just acting rude.
I'm gonna come back to this after the next thing we do.
Alright. Alright.
Alright, M&M time!
Wait.
That was my last
Did Max
Okay,
get created for
so-
next year?
Huh?
Did Max's class get created for next year?
I think so. I need to go ask. I haven't heard otherwise. I've heard otherwise on BC Cal, so I'm assuming you, Matt.
Oh, you guys are not having BC?
Harp pedal fall.
I know, right?
So sad.
Rose and Rose.
So I guess you just do BC Cal, or Cal 2 over the
Voice
summer,
cracker's crazy.
right?
No, I'll do
Alright, so real quick, here,
Yeah, I'm not doing that.
Hey,
My friend goes,
do y'all still have your data from when we looked at the plain M&Ms, or do you want to go ahead and eat some more plain
More.
M&Ms?
Eat some more. Eat
I
some
don't even
more.
know why you even asked that.
Like for real.
Alright,
I lost.
y'all don't
my
have,
page.
oh, there you go. I say y'all don't have paper towels in the, y'all's bathroom, do you?
We do.
Can someone go get some more?
I will.
What's the biggest contributor to the weight of the class?
So it's like 8 of y'all, 8 of us in here?
That was definitely him.
Huh?
It's 8, no, it's 7. Where's
So,
oh,
we're missing
Sprig's not
Sprig
here.
and the Braden.
You have to, right?
Oh my god, I ate so much cake
There
pie.
you go. You over right there.
I ate so much. Why is it already open, Mr. Kenny?
I got hungry.
You wanted some?
I'm
They're late.
hungry, I gotta get hungry.
It's literally Mr. Kenny.
I don't think you understand how much I like peanut
Are
butter.
you going to, award tonight?
What is it?
The senior award night?
Yeah.
Me?
Is that tonight?
Yeah.
Oh.
What do they do?
No,
What's
We're
ours?
already working that, or
Is
if
it every year? The senior award night?
Yeah.
I guess. I never
I
heard.
don't know if I want to go or not.
Sometimes
I know I'm getting something, I just don't know what.
I thought it was for like scholarships only,
It
basically.
is,
Sure
but
they do.
but she hasn't told me like whatever I got, so I'm gonna go to Miss Johnson and ask.
She don't ask if she's in the evening.
They're probably-
I know she was so annoying. when
Dude,
people asked
watch her
me.
be like, you better come to the thing to find out.
Right. I know that's what she said. Like the reason I go is to like, if it's good.
The thing, the
okay?
Oscars.
Like, you wanna, you.
Like
you
if
wanna
it's something
go
like
to
good,
go.
obviously
Where's
I'm
my
gonna go.
phone?
But like if it's like nothing, then I don't know.
Put that there.
Probably you.
Senior what?
Okay, that's nice.
I don't know.
Here you go.
I don't tell my parents stuff.
Here you go.
Thank
Here
you.
you go. You're so welcome.
I don't know.
Okay, I see my efforts were clearly not appreciated.
Oh yeah, sorry, I already had some, but
you
they
can have
need
mine.
Okay. Well, you have extra for next time, I guess.
Alright, so I need you to again count up the colors for each of
You
these.
just
Why
hate
did I get
us.
no red? Yeah, that's
I made sure you did.
We're gonna be the biggest.
Oh, we get more?
Actually, do you know why you didn't get red?
Stellinger.
Oh, there we go.
Such a.
So we're the biggest.
Math
That's so
stats teacher?
racist. Wait.
What?
Wait, what you
Can
say?
we do like a
Sampling variability.
Oh, I thought you were making a race joke. Cause I thought I don't want to talk about it.
I don't understand what race joke I could have possibly made.
I probably don't anything.
You said you can
I'm
make
not
another
so
race.
No, I cannot.
That's true. You just said you can make
Two
another
things
race.
else is true.
God, bro.
Sounds about right.
Dude.
What the freak is wrong with you?
Is your parents showing up?
Alright, start counting up your
It's
colors.
right there.
Alright, time to check your date.
Oh, no, that's Serena's favorite day of the year.
What?
Huh?
Yeah, it is.
Today,
Yeah,
not
Why did you get all orange or blue?
I
Why?
didn't want
I
to
don't know,
because you
I
don't
kinda
like
don't want
yellow.
her to know, like.
Bro, you actually found yellow. I saw you.
Oh,
You had yellow in your hand and you didn't give it to me. I saw that.
No,
You obviously don't like yellow.
Talent makes.
I literally
That was funny, and you know it.
I saw you. You had
Did you try
it.
Auburn on the board the other day?
That's not a bad.
Dude, he had a yellow one in his hand and he didn't give it to me.
That's not true.
Yes,
I
I
did.
swear to he did.
I actually did.
You just altered our
Did
data,
it
bro.
happen or no? That's still that's not that bad BS.
You just altered our
That was
data.
only one data point, right?
Oh.
I can't affect it that much, right? Surely.
It's like, it's good, I mean, it's like, hopeful.
You did it.
Yeah.
Funny.
Watch us be like slightly over the beat over
Just because of one yellow.
Well, obviously, I'm fine.
Dude, I got so many browns.
Oh, is that bad?
No, it's
Oh.
just weird.
Yeah, why do you
Like
put-
I got more
I got
browns than like
some
3 of my
browns.
other colors.
Alright, do this for me, because if you look at the sheet, I have brown first, right?
Uh-huh.
So, tell me how many plain brown you have.
Bro.
Three.
I don't
We start now?
So 0 plain brown, Michael,
5.
5,
Oh, wait,
2,
I'm
so
not.
7,
I have 4.
11,
I got 4.
15,
No.
3, 18,
I thought you said
24, 10, so 30.
Oh, I know.
Alright, now I need your brown peanut M&Ms.
I thought we just, oh, okay.
There's brown peanut in there?
Are you drunk?
2, he didn't get any.
Oh.
2,
3.
5,
But yeah, I feel like 15.
1.
6,
2.
8, 10.
Look at me.
Okay? We're going into yellow next. So
Uh-oh.
plain yellow.
That's the least favorite.
5.
5.
Dude.
That was funny. That was funny.
What's next?
Yellow,
Yellow,
plain
brown.
yellow.
That's the joke I thought
9,
Mr. King
11.
had made.
What?
4, 15, 20,
8.
11.
28, 2, 30.
Wait, 6. Did you read mine?
No, I already got you. Wait, you had 6?
Yeah.
11, 13. How many did you have on? 4? 17, so it's 2 more than I said. So 32. Alright, so I need peanut, yellow peanut.
I got 5.
2, 3,
2.
5. How many?
2.
7, 9. So 9?
Yellow, right?
Yeah,
I lost my mind. 4.
13. Okay, red, plain red.
6.
4.
10,
5.
15,
4.
19,
2.
21, 29,
2.
31.
31.
Oh, we talking about red. My bad.
Oh my.
5. I was going in the order of my
Order,
thing.
yes.
My bad. My bad.
Alright, so peanut red now. Red peanut. 4, 5, 6,
6.
0.
12,
3.
15, 2, 17. Okay, orange. Alright, so plain orange.
4.
5.
5,
14.
14,
8.
22,
7.
29,
6.
35,
6.
41. Alright, orange peanut.
9.
7,
7.
16, 23,
3.
26,
7.
33, 37.
7.
What did I say for yours?
4.
No, what did I say when you said that?
Someone
You said
said
37.
I said 37,
Someone
and you said
7.
7.
And I, yeah, mine's 7.
44. Okay. Green,
Oh,
Plain
7.
green.
7.
7, 5, 12,
7.
19,
4.
23,
8.
31,
2.
33,
6.
39. Alright, peanut.
Oh,
One.
1,
Wait.
4,
For green?
5.
Wait.
9,
4.
13,
5.
18.
For green? Is
Alright.
my code?
It's like my cheeks.
Blue.
What?
I don't know why I had to look at the
8.
chart. but-
5, so blue, plain blue now.
13.
So 5, give 7,
Yeah.
12,
It's the
20.
picture for me. That's so mean.
2.
That is so
22.
mean.
4.
26,
2.
28, 29. Peanut,
Bro.
8.
7.
8, 15.
Which color?
Blue.
Dude, the last one left.
Yeah, right? 21,
5,
26,
6.
Sorry.
32,
5.
37,
Eight.
45.
what's that like going on in your head? I see you look
Oh
up
my
every
God, I
time
just
somebody-
remember-
Huh?
Yeah.
He counting in his
Yeah, I
head.
know, but like.
What do you ask me?
When
When I look left, like left side of your brain is the logic side, so that's the.
That's,
That's not how it works.
that's,
Okay, Brent.
No, but your left eye, not looking to the left entirely.
Bro, what?
I'm doing this. I'm looking literally like, that's why I can't,
well,
anyway.
are you trying to look at your brain for it to do the work?
That's not
Don't
how it
you?
works.
I
I look at the ceiling.
So, important question. So, legitimately, this is kind of built off of something I'd seen before, but it's a legitimate question I had. I was always wondering if the color proportions for peanut and plain are the same or are consistent across different types of M&Ms. And so we're gonna find our totals in a second, but first I gotta ask this question: why can we not use a chi-squared goodness of fit test to determine if the colors are proportional across plain and peanut?
There's two samples.
There's two samples. We need to recognize, right? If we have more than one sample, can I do a goodness of fit? What else about this setup tells me right away I'm not doing a goodness of fit?
Two-way table.
It's a two-way table, right? We need to recognize goodness of fit is only one sample and how many variables?
2, 1.
I don't know.
It's one variable but multiple categories, right? It's not just one proportion, it's multiple. So I need you to think through, should we conduct a test for association or homogeneity? Take 30 seconds, talk with your group.
I mean, there's two.
Right.
Homogeneity, right? Did you know what?
Sometimes I have one.
Did you get
Sometimes I have
homogeneity?
one from the
Yeah.
Because it's one variable, two
You
samples,
finished
right?
doing your
Consistent.
physics.
Same. Two.
Yeah.
Two variables.
Then,
I mean, yeah, two samples.
One variable.
What are we doing?
you know.
So
Are we trying to find an association?
homogeneity,
No, it's homogeneity.
homogeneity is two samples, one
I
variable.
love homogeneity.
Okay.
These peanut M&Ms are so good.
It's just,
He's advocating for using a calculator and he's using his money. I think that's really ironic.
Why are you taking so many
You
pictures of my
made me lose my
M&Ms?
count.
Happy Pride.
Fine.
If you want my M&Ms, I bet just
Happy Pride.
biggie.
Happy Pride.
You're just trying to eat all my M&Ms. Why is this one so long?
Alright, so test for homogeneity or test for association?
Anyone else?
Homogeneity,
Yeah.
homogeneity.
Homogeneity.
What'd y'all come up with, Michael?
huh?
Did y'all talk about it?
Yes.
Why? Okay, so why is it homogeneity?
Because they're consistent.
Because we're asking, are they the same? And specifically, we're asking if two what are the same?
The population.
Distributions.
Oh, I lied. Never mind.
Distributions for populations. Remember, we're looking at two populations, okay? So I need us to recognize that what we're looking at is two different populations and we're asking if they're the same. That's how we tell what type of test we're looking at. Are we looking at two different samples and asking about two populations, or are we looking at one sample and two different variables, okay? So what I now want you to do, we'll go back to that previous thing in a second, but I want you to conduct a test to determine if the colors are proportional across plain and peanut M&Ms. So conduct a test with each other, help each other out, see if they are proportional.
I have a different.
Wait, I think they're four, is he saying?
Would that be important for such a test?
Yes.
A little bit of review today. So notice I did our choose, I did the check, right? So there is no difference in the color distribution for all plain and peanut M&Ms. There is a difference. Both samples are random, 209, and so I do want to clarify this because I understand why it's a little confusing. Really, you probably should separate as two different things, but I did it respectively. So 209 and 155 is less than 10% of all plain and peanut M&Ms, right? They're two different samples. You have to check the 10% condition for both samples, okay?
Oh, is there a difference between how you write and the plus?
Yeah, that's my hand.
Oh.
That's my hand. Okay.
Oh,
What
a lot of legs. So
am I
many.
missing? Anybody see it?
They can't
The picture.
The large count.
Thank you. Don't forget your large counts.
I don't even know if you do that.
Choose, check. Actually, this is actually a good point. Make sure you clearly label stuff on your test, right? On your AP exam. Make sure you check your large counts. So what was the smallest expected count?
18.74.
It was what?
18.74.
It was what, how much?
18.74.
That was not the smallest
You'll be needed,
expected
you'll be
count,
nice.
was it?
It
Oh,
was.
It's
Let
okay,
me
you don't have
check.
to be nice all the time.
wait, was it?
You're respectful.
Oh, say that one more time. What did you think it was?
18.74.
No,
18.
you go out your way.
I
Which
thought
way
you-
means you
I heard 80 that whole time. I was like, there's no
Dude, you're
shot.
actually really deaf, like, I'm not gonna lie.
Well, I'll do
That's how you
I
come
was like,
through that water in my eye.
It is 18.
Two for
Wait, what?
two.
7-4.
I was mumbling from the back of the classroom.
Nah, he alright now.
Hey, do y'all have this down?
Yeah, I actually do.
The smallest count to check our large counts?
I have 80%. No, excuse me, like
Yeah, the smallest
95%.
That ain't 100.
Okay, well, statistically speaking, next.
So the smallest expected count is 18.74. That's greater than 5, so we're good, right? So that's checking all of our conditions. And then we have our calculations. We got our p-value. So what should we do now? Conclude, right? What conclusion are we gonna have? So
There is
reject.
physical evidence for the alternate hypothesis of
The null.
Should I become one of those like engineers people?
No.
No.
Dudes who pretend to read really fast. On the TV. Like pretending to read really fast.
What's wrong with
Oh,
Indian
the
people?
fixing?
Oh my
Like
gosh.
fixing the tool, like the appliances.
I'm
And
shocked
the
never
difference-
vibrated.
there is a
We got some
difference.
textbook. It's like.
And the
I think Chris him on after. It's dumb. He never did it.
there's a difference in the color distributions plain and peanut M&Ms.
I'm tired and cold. Stop trying to steal my M&Ms and Biggie. Oh my god.
Are there any? Is there anything I'm missing?
The
follow-up.
biggest contributing blah blah
Take a
blah
whole
blah.
thing.
Actually, give me
Is that the only thing I'm missing?
We got content.
the biggest thing factor.
Is that the only thing I'm missing?
Did you compare them?
The
alpha
comparison of the
value.
p-value and the alpha.
Gotta compare the p-value and the alpha, right?
Right.
So since the p-value equal to 0.00012
Jamie,
is
I'll give you this.
112 is less than alpha equals 0.05.
No, this will take.
There is convincing evidence. Yeah, what was the largest contributing factor for this one?
The
I'm
blue
trying to look
plane.
through the list.
Blue plane?
Yeah.
Okay, so I'm gonna move that back up in a second, but yeah, let's look at it. So I'm looking here.
Isn't it
Look, this-
blue?
this
Isn't it
one's-
blue peanut?
No, it's blue plane. Look, this one's split.
Isn't it blue peanut?
No, because blue plane is 4.28.
No,
and
look at
peanut.
blue.
I don't know, I see a 5.77
Yeah.
in
There's a
here.
5.77.
Look at the very last one.
It's the very
Oh.
last one,
Sorry.
bottom right.
I can't see that.
Yeah. So if you look right here, I know it's harder to see, but look, 5.774, so that is the very last data point in the bottom row. And what one was that?
Blue peanut.
Was that blue peanut?
Yeah.
Okay, so we would want to include that follow-up analysis. Could you talk about more than just the blue peanut, by the way?
Sure.
I think there was like 3 of them that were like 4s and
Yeah.
5s.
Yeah.
So the blue peanut contributed the most to this discrepancy.
So did you talk about the ones that are like higher than what? Higher than 4
So
or like
you
the
just
largest?
you talk about the ones that have the largest contributing
You
factor,
lost one.
right? So when I go
Last
back
one.
and I look at this and I look at this component matrix here, so notice that's 3, 1.5, 0.75, 1.25, 0.075, like that's not doing much, right? I'm adding all those values together. 4.28, that's pretty big, 4.07, 1.98, 1.02, 1.68, 0.1, and 5.7. So that 5.7 contributed the most to the chi-squared, but it probably would be good, I would probably say 5.7, 4.1, 4.3, maybe even that 3.0. Those 3s, 4s, and 5, and the 5, or the 3, the 4s, and the 5 are contributing the most. It wouldn't be bad to say, hey, these are the ones that contributed the most to that chi-square test statistic, or the largest discrepancy between the two distributions. Okay, ready for some review?
Should we do
Yeah, I
it all
guess.
every time, or only ask?
Whenever you fail
What I have seen recently is if they give you a chi-square two-way distribution on the free response, then do a follow-up analysis if it is statistically significant. If it's not statistically significant, then it doesn't matter.
This M&M doesn't have an M.
No.
Oh.
All right.
Okay.
So, what did I have?
Say all my M&Ms.
Oh.
I
I'm
thought
gonna get an M&M with an
I
M.
put some stuff in here. Apparently not. So I have marked a couple of the progress or the probability questions because Serena specifically was asking about those, and I have done. I took names out. I think. Yeah. I did an analysis of all the questions on the on the mock exam to figure out which questions we should look at. That's why, Peter, I would say do that soon because that's one of the things we're going to start tomorrow.
Distribution.
No, the mock exam.
Oh,
The
yeah.
2019 mock
Wait,
exam.
tomorrow?
We're going to start going over it tomorrow.
Dang. I'm gonna every
It
weekend.
ain't funny.
Okay, we can do it Monday. We can do free response
Um,
tomorrow.
Yeah,
All right.
cause you just play. I ain't gonna lie.
It looked, it was like,
Gene, it took me an hour and a half.
Well, I could just step out.
I mean, the
That's how much time
questions
we had.
felt.
You also, if you can get done, cool. We'll do it tomorrow. If not, we'll do free response tomorrow.
Peter, don't stress yourself out. We have
Yeah, I'm
other
going to
stuff.
bed. I'm not doing all that.
Yeah.
I respect that.
Thank you.
Yeah.
tomorrow
I
Thursday or
will
Friday?
give y'all a couple
Friday.
free
I thought
response
the
questions
same
to
thing like
do
2 days
over
ago.
the weekend because we need them. I
More
will
what?
also develop some more review stuff like this. Okay. So question
alright, if I make this go up to.
one was actually one of the ones I was asked
Yeah.
about.
Oh, wait, we're to the staying school.
Mr. Kenny, I have a question.
I might have an answer.
Aside from me, like, are you still coming like to fourth period when the exam's over? Like, say I didn't need the
It's
extra,
his job.
I have a job.
but not fourth period.
Still,
This is-
I'm still a
Yo,
teacher.
what?
I didn't know
Fourth
you had
block.
to say.
Isn't it?
I'll be here.
I'm gonna be here too. I'm gonna
Y'all-
be like,
The juniors are technically supposed to still come here every day.
after exams, you don't have to. I mean, after midterms, you don't have to come.
Yeah,
Not
but you don't have
midterms,
people
but
like-
mock, not exams. Dang.
I'm just letting you know, last year, I had a project after the AP exam.
Oh
I'm
my
gonna be
God.
here anyway.
I said last year.
Oh, okay.
I'm gonna be here
Look,
regardless.
How
That's
did
all
you
I'm
say
gonna
Me
do.
too. Okay.
Was it very interesting or not?
Huh?
Was it very interesting or not?
It was more fun than the first project because everyone had better understanding of inference
What did
procedures.
it
Some of them were better than others. I'd have to go back and look. There was one about like a dog chasing different colored tennis balls, and it didn't work out very well because it just came down to the dog, not the color of the tennis ball. So lots of confounding factors. Anyways, okay, so this is one of the more missed questions. So the distribution of number of hours worked by volunteers last year at a large hospital is approximately normal, with a mean of 80 and a standard deviation of 7. Volunteers in the top 20% of hours worked will receive a certificate of merit. If a volunteer from last year is selected at random, which of the following is closest to the probability that the volunteer selected will receive a certificate of merit, given that the number of hours the volunteer works is less than 90? Whew. So what do we need to do?
Inverse.
Inverse norm.
So I would definitely think inverse normal. There's something else though that I feel like y'all are skipping.
This is top 20%.
So here's the thing, y'all are looking over here, and this
Uh,
is good
First
information.
you gotta do less,
You gotta do
do
0.8.
90 as well.
Let's do point
So
eight.
remember
It is-
to really focus on what the actual question is asking. Is this important information?
Yeah.
Yes, but what we want is the probability that the volunteer selected will receive a certificate of merit given the number of hours is less than 90. So what are we really dealing with? What do we gotta think about?
Conditional.
Normal city, yeah.
Conditional, right? So this is the probability of merit given the number of hours is less than 90. But, right, now we gotta know what does this need to be, right? And you,
Probability of merit.
Yeah.
now is it normal or is it inverse? And how can we figure that out easily?
How many people got this question right?
I don't remember this one off the top of my head.
I did this one.
I will point this out. My mean is 80.
Yeah.
Okay? Standard deviation is 7.
Oh, are you scared?
No.
Oh, okay.
Okay? Who's getting a certificate of merit?
People in the top 20%.
And the top 20%, right? So I know that the top end is 20%.
But then you have to
I need
limit
to
it to
know-
90.
Yeah, I need to know what that is, right?
I just did 2 Z-scores.
Right. I would exactly do two z-scores, but to get that z-score, I need a what?
Inverse normal.
Inverse normal, right? So this would be an inverse normal, because I have an area. What's my area going to be?
I forgot.
0.8,
Why 0.8?
because the add up below.
So remember, inverse normal, we always have to do is the left side. So the top 20% is over here, but we always got to do that left side. So 0.8, mean of 0, standard deviation of 1. What was that z-score? Glad Jaden's typing it in. Anybody else have a calculator that's typing it in?
I don't know if you all.
Because y'all might need some practice with this.
I'm not doing all that.
Oh, Jaden Dow!
I'm not doing all
I
that.
got it right yesterday, so I can get it right today too.
Pick that calculator.
0.8416.
Okay, 0.8416.
Yeah.
All right. Now, I still need the associated z-score with this, right?
80 minus 90 over 7.
You, what? Oh yeah, what, no.
Oh, 90 minus 80 over 7.
Remember, it's a value minus a statistic or value minus the mean divided by the standard deviation. Let me ask you all a question, because this actually threw me off for the first couple of years I was teaching stats, or at least first year. Why am I not dividing by the square root of the sample size here?
Oh.
Okay. Cause it's not
It's
a.
not a
We have
sample.
What's it called?
Standard,
It's not a sample.
It doesn't matter
Deviation.
what sample size it is.
with the standard deviation of the,
That's not standard.
It's not a sampling distribution.
Say that one more time.
It's not a sampling.
It's not a sampling distribution. It's not multiple data points. It's
Just
one individual,
Doesn't matter.
right? If I was thinking about it, and so I think that's what you're trying to get to, Lana. Like, if I'm recognizing that there's only one data value I'm looking at, what is n? It's
1.
1. Divided by the square root of 1, doesn't matter. So it's not a sampling distribution, it's one single value. So what is that, z?
10 over 7.
Thank you, like 1 point something. Okay, so what I want,
I'm so
so how am I gonna use this information now though, to answer that question? Because there's still more going on.
From the 0.8416 to the 10 over 7.
That's not all it is.
What?
What?
Remember, this is a conditional statement.
Random.
This is the probability of merit and less than 90 hours
over,
divided by the probability of
yeah.
less than 90 hours. You gotta calculate both those probabilities. There was a lot of probability going on in this problem. But that's why, like, I told you, don't skip this. I would have written this out from the beginning, because then that's gonna get me back to my normal distribution. Yeah, I need this information right here, but I also need to divide that by this probability. So find your probability, your area inside of here, and divide it by the whole thing for less than 90. Or don't focus on your music, whatever.
We have a concert on Monday and I haven't looked at
Yeah,
it.
2 more minutes, you could have
That's
focused on this.
2 minutes. 2 minutes.
Yeah, it is 3:13.
No, it's not. Oh, yes, it is.
Yes,
No, it's not. Yes, it
it is.
is.
Mr. Kenny, you're wrong. Oh, wait. I guess I'll do it for you.
That's mine.
Not that I have to take the exam soon. What was it, 0 or 10 sevenths?
Yeah.
So that, no. Was it 0.8416?
Yeah.
Have you guys watched all yet?
I don't know if
And
it's.
so-
Tam Tam.
I just take this value, divide it by
I know.
that value,
So.
and there she
That's a
is.
great question.
I don't forget y'all, Bill.
So, Michael, if you don't want those M&Ms, I'll gladly.
Yeah, you can have
Yeah,
that.
you can take these.
Dry with no skull.
No, that's mitosis and telekinesis.
Yeah, it is.
The rest of you guys hate
I don't like that.
They play with y'all.
Did you do sketchy things for them?
No.
Okay.
He rubbed them on his feet.
Ew.
Yeah.
I